Okay, so once again, this is the final section of 1.6. This is where we write absolute value inequalities given the graph on a number line. But before we do that, let's jump and do some warm-up problems. So we have a compound inequality right here with the word or between it. Be great to write that down. We're going to solve both of them. You're going to get two answers. Of course, you're going to have the word or between those answers. And you got to analyze the graph, right? You got to graph the inequality on a number line. If the areas are apart, then yeah, your answer will be both inequalities with the word or between them, because the word or implies that it's going that way or that way. So if they're apart, yeah, you keep the whole thing with the word or between it. But it might be a special case inequality like we did yesterday, where they're both pointing in the right direction, and then you got to know the difference between the words and or, and select the appropriate one. Let's do this. Number one, again, these are not absolute values. These are parentheses right here, so you distribute, right? Negative 2 times x is negative 2x. Oh, that's ugly. Negative 2 times negative 1 is positive 2. Bring down the greater than, bring down the 5. Continue solving. Subtract 2, subtract 2. You will end up with the negative 2x that comes down, the greater than, and 3. Now for my final step, I will divide by negative 2, divide by negative 2, giving us x is less than negative 1.5 or negative 1.5, whatever you want to call it, right? But we did divide by a negative, that's why we flipped the inequality symbol. Now let's do the other one. The other one's a little complicated because it's on the right side, the variable's on the right side instead of the left side, but that's okay. Let's get rid of the 7 by subtracting 7, subtracting 7. 5 take away 7 is negative 2. So we have, let me change colors here. Negative 2, bring down the inequality, is less than negative x. So for my final step, I need that x to be a positive x, not a negative x. So I could, if I want to, divide by a negative 1, or if I wanted to, I could multiply both sides by negative 1. Either way, it's our last step, and whether you multiply or divide by a negative 1, on your last step, you have to flip that inequality symbol. So what we have here is x is less than positive 2, if you read it backwards, of course. And we have the word or between it. And let's write it with the x on the left side and the 2 on the right side. I mean, this was the correct answer, so it was opening up to 2, so it needs to continue opening up to 2. So this could be our answer. Right? As a matter of fact, one of the multiple choices will be this as your answer. But you can't be for certain that this is your answer yet until you analyze the graphs of the inequalities. So let's go to a number line, and we're going to plot the point negative 1.5. It's somewhere in the negatives. Over here is 2. We know that 0 is somewhere in between. Looking at this first one in blue, it says x is less than negative 1.5. Less than's to the left. And looking at I guess we'll do this one in red, x is less than 2, less than's to the left also. That's weird. That's what we did yesterday, special cases, all right? Most of the time, when you have the word or between it, they'll be going apart. And if that's the case, you just write this as your final answer with the word or between them. But since they're both going in the same direction, we have a special case. And the way I help myself remember the difference between or and means both, right? So if I said, where do you have both the blue and the red, it would be from here that way. That's with the word and. So if I had the word and, it would be this inequality right here, the blue and the red going this way. But the word or, it could be the red one or it could be the blue one. So where's the first one that you see? You see this red one first. So that's this one right here. X is less than 2. I got a feeling that I'm not explaining this the best that I could be. Does it make sense? Yeah? Okay, the word and would mean both, which would be this inequality over here, x is less than negative 1.5. The word or, it's either one or the other, so you're going to begin with the first one that you see in the direction that the arrows are going, which would be x is less than 2. So what is our final answer that we're going to put on our answer key? X is less than 2. You're not going to put that one right there. Just x is less than 2. Special case. Same type of problem. Let's do number 2 right here. So when we solve this, plus 5, we end up with negative 3x is less than 6. Final step is to divide by a negative 3, which means if you're dividing by a negative on your last step, you have to flip that inequality symbol. It becomes greater than, of course, negative 2. Let's do the other one. Plus 1 plus 1. We end up with 2x is greater than 2. Final step would be to divide by 2. Divide by 2. We're not dividing by a negative, so this is not going to flip. It's going to stay greater than 1. And we, of course, we have the word and between the two answers. Now the thing is, most of the time the word and implies that it's between two values, so we'd write it as a compound inequality. But in order to really determine that, we need to go to a number line. Wow, that's ugly. Let me do it again. Go to a number line. We have the negative on the left side, the positive on the right side. Of course, 0 is right there, negative 1 is right there. And let's graph these guys. X is greater than negative 2. Greater than is to the right. And x is greater than 1. Greater than is also to the right. That's weird. So how do we do this? I highly recommend everybody extend your lines. So this red one, look at, I want to extend it all the way this way forever. Okay? And same thing with the blue, all the way that way forever. Now, the question is, do we have the word or do we have the word and? Obviously, we have the word and. What does that mean? When you say red and blue, you're talking about both, right? Red and blue, both. So let me ask you this. Do you have red and blue over here in the negative 3? No, you don't have neither of them, right? Do you have red and blue right here on negative 1? No, right? If it were the word or, yeah, you would start right here. Because it doesn't matter if it's red or blue, it's red, okay, so that's where you would start if it were or. But the and is only, where's there only red and blue? It starts here, red and blue, and it continues this way forever. So obviously that's this inequality right here. Let me highlight it in blue. Everything going that way, right? So that inequality is the x is greater than 1. Did that clear it up? Okay, I hope so. All right, let's do another. The left one, super easy. Subtract 1, subtract 1. You have x is less than 3. Boom. Then we have the word and. The other one, plus 2, plus 2. We end up with negative x is less than 8. Now we need to divide both sides by negative 1. Or you could multiply both sides by negative 1. Either way, on your last step, you are multiplying or dividing by a negative, which means you have to flip the inequality symbol. X is greater than negative 8. So we have this answer, we have this answer, and we have the word and. Let's think about what they look like on a number line. We have the negative 8 over here on the left side, the negative side. We have a positive 3 over here on the positive side. You could put a 0 in between them if you want. Let's do this one in red. X is less than 3, less than's to the left. Let's do this one in blue. X is greater than negative 8, greater than's to the right. And what do you know? This is the regular old type of compound inequalities. Areas are together. We have to write them together, right? And it's really easy to do that. All you do is put the x in the middle, the smaller number on the left side, bigger number on the right side, which if it's already in a number line, it's already on the left and on the right. And then you just put the inequalities right down there, and there is your answer. You see, it's easy. Okay. Let's do, you guys want to do another one? Yes, please, one more. Okay, let's do one more. This one is more hypothetical. Let's pretend that you have two inequalities, right? And there's the word and right between the two inequalities. So you're solving them, you do all kinds of steps, and you finally get the following answers. And these are the answers that we get. We get x is greater than 1. Of course, we said we have the word and between it, and also the other answer, x is less than negative 2. So what's your final answer going to be based on this? So in order to determine what our answer will be, we've got to think about the number line. Let's put the smaller number on the left side, the bigger number on the right side. Obviously, 0 is right here in between. Let's do this one in blue. X is greater than 1, greater than's to the right. And let's do this one in red. X is less than negative 2, that's to the left. Now, if I had the word or between both of these, then that would be my answer, both of them with the word or between it. But it has the word and. And what does the and imply? That you're looking for the area that has both the blue and the red together. Where on this number line are the blue and the red together? Nowhere. So what do we say? No solution. There's a no solution symbol, or you could write no solution. Anyway, I thought those are pretty cool. Yeah, why not? Let's do that. How about x is less than 2, or x is greater than 0? Let's say you had a complicated looking inequality, another complicated looking inequality with the word or between them. You solve both of them, you get these answers. X is less than 2, you bring down the or. You bring down x is greater than 0. Those are your answers. How are you going to represent your answer? I mean, would the whole thing be the answer? Would just this one be the answer? Would just this one be the answer? Or is it like none of them? I don't know. What do you guys think? I hope I don't confuse you guys with this one, right?
You are.
'Cause it's like we're going on another level. It's so easy that you might get confused. So when we think about 0 and we think about 2 and we think about x is less than 2, it's technically going that way. And when you think about x is greater than 0, it's technically going that way, right? So it would have been nice if there would have been an and, then you could have written it as a compound inequality written together with the 0 on the left and the 2 on the right, with the x in the middle and the less than symbols, if it were and. But the word or doesn't limit you to just the overlap. That's the word and. It limits you just to the overlap. Okay, so right here, the blue one continues this way forever, and the red one continues this way forever. So in reality, it's all real numbers, because any number over here will land on the red, any number over here will land on the blue, and of course in between it lands on both. So this would be all real numbers. All real numbers, that one, the 2 sticked R. 2 sticked? I don't know. Made that up. You could put all real numbers. You know what? I won't give this one on the test tomorrow. Yeah. Okay. Okay. So, but we still have one more type of question that you're going to see on the test tomorrow, and that is where I give you a specific. I'm sorry. Friday. Where I give you a graph. Check it out. I have a graph down here. All right. So how about this? Don't copy notes right now. Let me show you how to use the notes. That way, it'll make sense to you when you copy it down. Because if you just copy it down without knowing what the notes are about, it's not going to help you. But let's take a look at this first example right here. And it says, to write an absolute value inequality, you start by doing the absolute values, the x, the minus, and in here you're going to put a number, and that number will be the midpoint. What is the midpoint? The point in the middle of your graph. Okay? And then over here is going to be another number. What's that other number? It's the distance from the point to the midpoint. So let's begin by looking at this number line and then doing the form absolute value x minus. Now, what is the midpoint of this? -3. Right? We could clearly see that this dot right here, that green dot, is the middle. That location is -3. That's the midpoint right there. Okay, so that value goes right in here. You just, whatever the midpoint is, that's what you plug in right there. And then you have the equal sign, but we know that equal produces 2 answers, not an area of answers, so we know we need inequalities instead of equals, all right? And that's where this sentence of notes comes in. But instead of an equal sign, you need an inequality. If the areas are apart, you use greater than. If the areas are together, you use less than symbols. Now, why did I put greater misspelled with the OR? Because we could associate the word or with the areas apart, right? And we could associate the areas together being and, right? So or is usually representing apart. So these areas are not apart. So I'm not going to use a greater than symbol. I want to use a less than symbol, right? So once again, if these areas would have been apart, I would definitely use a greater than symbol. So if the areas are apart, use greater than symbol. I put or in red because or usually means apart. So if they're apart, you use the greater than symbol. Since they're together, you're going to use the less than symbol. So here's my less than symbol. Not only that, these guys are solid dots. So I need a solid line underneath that less than symbol. And over here on this side, it says the distance from the point or from a point to the midpoint. So what's the distance from either this point or that point to the middle? 2. Okay, so let me do this. Let me show you visually. From here, it's 1 unit, 2 units. So that's where we get the 2 from on that side. And believe it or not, that is your absolute value inequality that would produce that graph. If you were to do the positive and negative situation and solve them both, you'd get that compound inequality answer as a graph. The only other thing, the only other thing that you could do to make this look a little nicer is change the minus minus to a plus. So absolute value of x plus 3 is less than or equal to 2. And this is what I'm looking for. I'm asking you to write the absolute value inequality of the graph. So now that you saw those notes in action, you guys could copy down those notes in your notebooks. Let's try a couple more here. Check it out. Let's do number 29 right here. Jot that down somewhere. They're open dots. It's going out away from each other. Now, keep in mind, what I want you to do is to write the absolute value inequality that would represent this. Now, if I just said write a compound inequality, yeah, you would put x is less than -4 or x is greater than -2. But what I'm asking you to do is to write the absolute value inequality that would ultimately produce this graph right here, okay? And of course, you need this format. This is what everybody should be doing. Absolute value, x minus, close the absolute value, leave a space right here. And then, what belongs in this space? Midpoint. Midpoint. What is the midpoint? There you go, -3. So put a -3 right in there. And then we need to determine if this is going to be a less than symbol or if it's going to be a greater than symbol, or it might be a greater than or equal to, or it might be a less than or equal to. I don't know. How do we determine whether it's a less than or a greater than? It's, somebody said greater than. Why greater than? What's the trick that'll help you remember greater than? Greater than, right? Tor, or. Or means that the areas are apart. So right here, the areas are apart, so it's going to be a greater than symbol. Greater, right?
If they were to meet, then it would be less than?
It'd be less than if they were, yeah. This is on writing absolute value equations, or not equations, inequalities. Okay, so that is a greater than, and notice that the dots are open. They're not solid dots. If they were solid dots, I'd put a solid line underneath it, but they're not solid, so I don't put the solid line. And again, the number out here is what? 1. Why is it 1? Because that's the distance from here to here. So that's just a 1 right there. And we're done. To make it look a little nicer, just put x plus 3 is greater than 1. And again, if you were to do the positive and negative situation of this, you'd solve them both and it would produce this graph above. What do you guys think? Pretty easy, right? Okay, let's do another. You don't need to, but you know, it's nice if you want to study something. It's in your notebook already. Does anybody want to tell me what to write as the absolute value inequality to this? Go for it.
It's absolute value.
Absolute value, x plus 9, okay. Because it was minus a -9, right? And that's why you're saying plus 9. Okay, that's good. So yeah, plus 9, because the minus changed to plus. And then
less than.
Just less than?
No, the solid.
with the solid line underneath, yep, because they're solid dots, right? So solid line, that's good. Less than because it's together. If it were apart, it'd be a gray tor. And what else? And 3, not 1, but 3, right? 3 out here. Why? Because out here, it's the distance from the point to the midpoint. So even though it looks like 1 unit, it's actually 3. From 6 to 9, it's 3. From 9 to 12, it's 3. So it is going by 3. So that number is 3 out there. Ta-da, easy peasy, lemon squeezy. Simple as popping a pimple in a dimple. That's gross, sorry. If you look at your worksheet that I gave you this week, right? We've had the same worksheet all week. We've just been doing piece at a time. So if you look at that worksheet I gave you on Monday, you'll see that the first 4 questions were graphs and you need to write the absolute value inequality. But I don't even like those because those are so easy that the midpoint is always 0. So those are going to be, you're always going to have a 0 right here. So you don't even have to put x plus 0 or x minus 0. You could just put the absolute value of x. But let's go back and do those 4 questions that all of them have the midpoint of 0. But I want you to be ready for these that have a different midpoint, okay?